Alright, this was routers class, the second day. We actually did quite a bit of stuff. I'll try to summarize it. We talked about today when you connect to a switch, you got pins 1, 2, 3, and 6. 2 of them are transmit, the other 2 are receive. So when the signal goes into the switch, it gets flipped over. So when it comes out, it came in on the transmit and comes out on the receive. So when we take and connect, and I don't have them in here right now, but when we took the routers the other day and we connected a router, for example, to a router, we would use one of those red crossover cables, because a router doesn't cross it over. Because in most cases, sitting out here on this Ethernet LAN would be a switch, so the router doesn't have to flip it over because the switch is going to do that. We talked very briefly about dynamic routes. Today we spent a lot of time on static routes. Okay? A couple of the commands. And so then here's the diagram. I'm not going to go through everything, but what we did was we expanded it. We went from here, we talked a bit here, and then we put on a LAN. We put on a LAN here, we put on a LAN here. And then it didn't take the students very long to figure out, in order to ping from that LAN to this LAN, they had to have some type of a route. So they put in a route and point it to the interface that it needs to use on the way out. By the way, they had to substitute the correct number in there. And so it didn't take long that they figured out they needed the static routes, and we worked on the extended ping to figure out how to represent our source address when we were working our way through. So they got very good at looking at the routing tables, looking at their interfaces, and we eventually have full connectivity through the network here by putting into each router enough static routes to point to our networks. For example, this router would have to have a static route pointing to here, pointing to here, and a static route pointing to here. We left off any routes to the connections in between because we really don't go to those except for testing. All right? So that allowed us to develop then static routing. Then our next step was this. We went in and we added this router up here, device 21, said that was an ISP connected out to the internet, and we put a couple loopback addresses in there, something like 210, 10, 10, 10, and 200, 111. And then we looked at our network and see if we could ping those addresses. Well, it didn't take very long for us to realize that, of course, we can't. We have no routes to them. Then, would it make sense to put static routes in our routers pointing at those specific addresses? Well, that wouldn't, because it's the internet. We don't know which routes we're going to want to go to out there. So then we figured out that in here we need a default route. So if it gets a packet and it's not on one of our local networks, not on this one, it's not on this one, it's not on this one, then we're going to default out to this router up here. And then it didn't take the students long to figure out that they'll need a default route coming out of each of their routers also in order to send packets to this router up here, which then sends them out into the internet. So we designed the default routes. This was a static route. Then we talked a little bit about the internet, and let me talk just one more thing before I end with this over here. So we have a default route pointing out, points to here, then this defaults up to here, and then the last issue was, how is this router up here going to know where to send it back? So we put a static route up there pointing at 10.10.0.0. So we could put one static route here pointing at 10.10.0.0 with a mask of 255.255.0.0. That'd be a /16. And so then it was just pointing at these parts here, which means then we only needed the one route there to point back into our networks. And if we added a bunch of 10.10. Whatever networks down here, we're still good up here because we're pointing to those. So it's a little bit leading up to the idea of summarization of routes and aggregate routes. And so I finished up talking a little bit about the internet, and maybe a certain provider has a 6640.00. So what the provider can do out here, it can subnet that address out and distribute it to all of their users. Could be literally thousands, but when any of those people come into the internet really is only going to need the 6640, because anywhere as it goes in the internet, whether it's in Europe or California or wherever, if it has a packet that's a 6640, it knows it's going to send it to this ISP. And then this ISP is going to figure out who, with all the people that are connected to it, that it goes to. So, broad view of the notes. On the board, and then to finish up, the students got the first lab wired up. Each student has a set of 2 routers that are connected, and they're connected so they can remotely access those, and we're going to take a look at those labs tomorrow. And that's it for today.